Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
We've been studying the unit circle and calculating angles and understanding those relationships within the unit circle for a while now. So now we're ready to start approaching trigonometric equations. Now the good news is that we can use the unit circle to guide us in this process. So I have a few examples to demonstrate that. Here's the first one. It says solve the equation over the domain where x is bounded between 0 to 2 pi. Now this will make sense in a moment why we want to bound our domain. Let's look at the first one. The sine of x equals 1/2. To make sense of this problem, let's actually sketch the sine wave. So to the right, I'm going to do a little scratch work and I'm going to sketch the sine wave, but I'm only going to do this interval. What is this equation actually saying? So this is asking you, what is the angle where if you take the sine of it, the output is 1/2? Well, graphically, here's what this means. If we find 1/2 on our sketch here, so just go halfway between your 0 and 1, so mine's about here, and draw a horizontal line. So what it's asking for is what are those angles that'll give this output? Well, look at our sketch. There's 2 of them. So they happen between 0 to pi. So let's think about our unit circle now. We know this is 0, we know this is pi over 2, and we know this is pi. So one of those angles happens in quadrant 1, and the other one happens in quadrant 2. So looking at your unit circle, what angle, so look in quadrant 1 now, what angle has a sine value of 1/2? So look at your ordered pairs in quadrant 1. Which angle has a y coordinate, because it's the sine, of 1/2? The answer is pi over 6. Look in quadrant 2. What angle has a sine value, which is the y coordinate, of 1/2? The answer is 5 pi over 6. So those are the solutions to this equation. Now, let's go back to this domain restriction. Remember, periodic functions continue forever. So if you don't restrict this domain, essentially there's infinitely many answers to this problem. So in these scenarios, typically you're restricted over a particular domain to consider. So in this case, we're talking about one complete cycle around the unit circle. And don't always assume there's 2 answers. There could be 1 answer, there could be 2 answers, there could even be 3 answers. So what's very helpful here is to draw a picture. We're going to use the same strategy as above. So we're going to look at 0 to 2 pi. So the first thing I'm going to do is sketch my cosine graph. So for this one, we're asking when is the cosine of some angle 0? So again, what is the angle that gives you an output of 0? So if the output is 0, if you draw your horizontal line, it's going to be the x-axis. And as you can see, there are 2 instances. Now, if your sketch is really good, then you can clearly see it based on your sketch. But if not, let's look at the unit circle really quickly. Now remember the relationship between x, y, and cosine and sine. So we want the cosine to be 0. So we're trying to figure out when is x 0. Well, x is 0 whenever you're on the y-axis. And so that means it's going to be pi over 2 and 3 pi over 2. And you can see based on your sketch, those are our answers. And again, we're restricting our domain here. If we don't restrict our domain, then we have infinitely many answers. Let's look at 2 more. Again, same domain restriction, 0 to 2 pi. This time, when is sine of x equal to 1? So let's sketch our sine wave. So we want to know what angle gives us the output of 1. So we're going to draw a horizontal line through 1. So we can see there's only one time it happens. And according to our unit circle, we can see that happens at pi over 2. And according to our sketch, it gives us the same thing. So this only had one answer. That's okay. That can happen. Let's try cosine. What angle gives us this exact output of -1/2? So we're down here. So find halfway between your -1. Now remember, it's just a sketch. So there's going to be 2 times this happens. Now don't rely always directly on your sketch, especially in this case. See, in this one up here with sine, we could see pretty clearly based on our values, we knew it had to be one answer, right? But this is an approximation. So let's go to our unit circle. The sketch allows you to kind of guide you into your quadrants and where to look. Now the output of cosine is negative, so that tells me I must be somewhere in quadrants 2 and 3 because that's when cosine is negative. Remember the relationship between points in cosine and sine. So because cosine is negative, I know my answers can't be anywhere in quadrants 1 and 2 because that's when cosine's positive, because that's when x is positive. So I can see I'm going to have some point, some angle between pi over 2 and pi, so that's somewhere in here. And then I'm going to have another angle somewhere between pi and 3 pi over 2. So that's in quadrant here, quadrant 3 here. So look at your unit circle. What angle will give you a cosine value of -1/2? Did you get 2 pi over 3? Now go to quadrant 3. What angle, when taking the cosine of it, will give you a -1/2? Did you get 4 pi's over 3? Those are our 2 answers.